So in this example here, we want to talk about comparing the birth weights of preemie babies versus full-term babies. So in 2010, babies born after a gestation period of 32 to 33 weeks, so we'll say a preemie baby, had a mean of 2,300 grams and a standard deviation of 715. So the preemie babies on their own, all of the preemie babies within that year had an average weight of 2,300 grams with a standard deviation of 715. In that same year, babies born after a gestation period of 41 weeks, so we'll call them full-term babies, had their own average weight of 3,520 grams and their own standard deviation of 480 grams. So we have again two different gestation periods. We have preemie babies and we have full-term babies. Now suppose a preemie baby weighed 3,000 grams and a full-term baby weighed 3,900 grams. Which baby do you suppose weighed less relative to their gestation period? So we want to compare who weighed less. Intuition's going to tell you that the preemie baby obviously weighed less than the full-term baby because that's the nature of the preemie versus full-term. But if I want to compare them to other preemie babies and other full-term babies, that's what we're going to do with this z-score. So we can read through this first sentence, and I'm going to talk about the preemie babies first, and I can identify that the preemie babies had a mean of 2,300 grams and a standard deviation of 715. So mu, because this is population data, of 2,300 grams versus with a standard deviation, I should say, of 715 grams. And then I'm going to scan through the rest of this, and I'm going to look down here, and it says, suppose a 33-week or preemie baby weighed 3,000 grams. So the actual baby I want to talk about, that individual data point would be the 3,000 grams for that particular baby. We can calculate the z-score for this preemie baby by taking the data point x, which is 3,000, minus the mean for the preemie babies, which is 2,300, and dividing that by 715, which is the standard deviation. When we put this into the calculator just like that, we should end up with a z-score of 0.98. In other words, the preemie baby's weight is almost one standard deviation away from the center. Now let's talk about the full-term baby. So the full-term baby, we go back to our paragraph up here, and it says the full-term baby had a mean weight of 3,520, a standard deviation of 480 grams, and that was for all of the 2010 babies. And then I want to come down here to my example, and the individual baby x is equal to 3,900 grams. So the z-score then for the full-term baby would be the 3,900 minus the mean for full-term babies, 3,520, divided by the standard deviation for full-term babies at 480, and we see that the z-score ends up being 0.79. So the full-term baby ended up weighing less than the preemie baby relative to other babies of their gestation period. So the full-term baby weighed less than other full-term babies compared to my preemie baby over here, who actually weighed more with other preemie babies. So that's what we're looking at, and that's how we use z-scores to be able to compare two different data sets that aren't the same. Here's another example that we want to look at together. This one is kind of a tricky one, actually. Here we have two athletes running a triathlon. Roberto, who ran the men's triathlon, and we also have Xandra in here who raced the women's triathlon. And you can see in here that the men had an average race time of 69.4 minutes with their own standard deviation of 8.9. And the women had their average race time at 84.7 and a standard deviation of 7.4. Now what you need to do is I need you to figure out who ran the faster race. Did Roberto finish at a faster time, or did Xandra finish at a faster time? I'm going to let you take a moment to pause the video, find the z-scores for both Roberto and Xandra, and then we'll see if you've come up with the same conclusion as I have. So here's the solution to this problem. Hopefully you were able to determine that Roberto's z-score was negative 0.7 versus Xandra's z-score of negative 0.73. But who ran the better race? Who ran the faster race? This is a little bit tricky because we're talking about negative values. Remember that if I win a race, I want to run it in the fastest time, or I want my time to be the fastest, I guess we should just say. So if we think about it this way, right? We're talking about z-scores. So here I have 0. And I'm going to put Xandra on my number line here. She's all the way over here at negative 0.73. That's Xandra. And then we have Roberto. Well, he's here at negative 0.7. So technically, Xandra is the one who ran faster than Roberto did relative to their gender. So this is kind of a tricky one. Hopefully, though, you see how you're supposed to calculate z-scores and then compare them to other sets.